Hey guys, so today I'll be showing you how to make this awesome transmitter which is completely based on the Arduino. It has an Arduino Nano for the transmitter part and also an Arduino Nano for the receiver part. So for this module I am using the NRF24l01 module for the wireless communication, as you can see here. For the transmitter and the receiver part, I'm using the normal NRF transceiver. For long range, as I am in the same room, I'm using this normal transceiver. But for long range, you can use the power amplifier NRF24l01 module, which is pretty awesome, which can give you a range of about 1 kilometer. So this transmitter is a 7 channel. As you can see, it has a 1, 2, 3, 4, 5, 6 and 7. The seventh one is in a potentiometer. So for the transmitter part, I'm using 2 joysticks. It is made for using with the Arduino. 2 joystick like this and an Arduino Nano and NRF24l01 with power amplifier. You can use, if you're making a drone, you will need this one. You can use this NRF with power amplifier for the transmitter and the normal one for the receiver, because the receiver don't need too much power, too much current. So I'm using this for my transmitter and also for the normal one for the receiver part. You can also use both the normal one for the transmitter or the receiver, but it gives you a short range like 100 meter or more or less. So I am using this switch also to turn on and turn off my transmitter. I have a potentiometer to add one more channel to this, and also I have 2 digital switch to turn on and turn off to send digital signal to this receiver, and also the joystick to send analog signal to the receiver. So this is my wiring. You can have the diagram of the transmitter next, or you can also have it on my website. I have dropped the link below on the description. You can go through it. So for this, I have cut wires to join these. You can have this strip board. You can easily find it on eBay or even on local stores around you if you have any electronic stores. So this is my battery port, sending 9 volt to the V-in of the Arduino Nano and connecting the NRF with a female header. As you can see, female header. I'm not using the adapter for the transmitter. If you want, you can use this adapter for the NRF transmitter, which is also available very cheap on eBay. I'm using directly the female header, which will connect the NRF24 to the 3.3 volt of the Arduino Nano. Remember to connect it to the 3.3 volt output, because this NRF works on 3.3 volts. If 5 volt can damage it, so remember to connect to the 3.3 volts. And I'm also using an electrolyte capacitor of 10 microfarad to reduce the ripple in the voltage. and the CE of the NRF24 I'm connecting to digital pin 9. The CSN I'm connecting it to the digital pin 10. The clock I'm connecting to the digital pin 13. The MISO I'm connecting it to the digital pin 11, and the MUSI I'm connecting it to the digital pin 12. Remember to connect these well, the clock especially to the pin 13, the MUSI and the MISO to digital pin 11 and 12. The C and CSN you can connect it anywhere on any digital pin, which you will configure in the programs, but the rest should be connected accordingly. I've connected the positive and the negative of the joystick to the positive 5V of the Arduino Nano. The positive 5V I'm giving to the joystick, and also to the digital switch. I'm connecting the positive and the negative to the Arduino Nano, and for the digital, the middle one should be to the digital pin 2, and 3 for both of these digital pin, and I'm connecting the joystick to another pin 0, anode A1, A2 and A3, and also the 7th, which is the potentiometer, to the analog pin 4. So after doing that, I can put my NRF back to this circuit, and I have this old RC plane transmitter cover, so I'm using this for 2 battery to power up my transmitter, connecting the negative to the negative and the positive to the positive, and I switch on my transmitter and it works. Please make sure that you have between 2.5 to 3.3 volt in the NRF transmitter, as you can see here. This one connecting it, it's 3.1, so it's good to work. Make sure it does not go beyond 3.3 before adding this NRF. Always check the voltage across this module. So it's 3.1, so it's good. I can put back my NRF transmitter, and let's get rid of this multimeter for a while. So this is done for the transmitter. You will have a diagram of the schematic in my website. Now let's look a bit about the transmitter. For the receiver, sorry, I made a mistake for the receiver. So for the receiver, the connection of the NRF24 should be made same. I'm connecting this digital pin 13 to the clock of this adapter. I have the NRF adapter here. I'm going to the clock, the CE to the 10, the CSN to the CE to the 9, digital pin 9, the CSN to the digital pin 10, the MISO and MUSI to the digital pin 12 and 11. You will also have this diagram how to connect this on my website. I will on the link below. So I'm connecting the LED to digital pin 2, the second LED to the digital pin 3, the servo to the digital pin 4 and this motor using the gate of the MOSFET to the digital pin 5, the drain to the to one part of the DC motor, and the source to the negative part, to the negative terminal. And remember to add this free-wheel diode to your circuit. I will leave a diagram of this MOSFET and the DC motor connection for this to work. You'll have the link for the diagram below. And remember one thing, that the PWM signal to control a DC motor speed is you cannot use any of the digital pin. There are specific pins such as the pin 3, the pin 5, the pin 7 and the pin 9 to control the speed of the motor. If you connect it to digital pin 2 or 4 or 6, this will not work. You will only have a specific voltage, a specific speed for it. So remember this to connect this source, the gate of the MOSFET to the digital 3 or 5 or 7 or 9, as it will not work. I have connected the servo motor to the signal to the digital pin 4, the positive to the positive terminal, and the negative to the negative terminal. So let's now see what this transmitter can do. You can control a servo using this transmitter. You can control a light, turn on and turn off a light from it using this digital switch, this one also. And also by sending a PWM signal, you can control a motor speed using it, which will be very useful for drones and RC plane. As you can see here, I'm connecting this wire. This is my motor with a propeller on it. As you can see, I'm controlling the speed of this motor. For this, I'm using a MOSFET. This MOSFET is connected to the DC motor, and using the PWM signal from the arduino, I am controlling the speed of it. As you can see the diagram for the schematics of this receiver parts next, and you can have it also on my website, which I will be providing you on the description below. So we'll now see the code for the transmitter part. So before we begin, you'll have to import the library for the NRF24 module, which if you don't have it, you can go to the sketch, include a library, manage libraries, and a window will pop up and it will download some file here. Once done, you search for NRF24l01 and you go down and you will find this one, RF24 by TMOH20. So if you go here, if you don't have it installed, if you go here, you will see an install button. You just click and wait for it to be installed. Just like this, you will find it for this one also. So once it has installed, you just have to go to the sketch, include library, go down, and you will find this RF24. Let's just click on it. You will see that it will be included in your project. So also include the SPI.h library, the RF24 which will already be included if you click there. If not, then also remember to import this library also. And we have this pipe out, which is the address for the transmitter and the receiver. Remember to make this the same as for the receiver also. It should be completely same, otherwise it will not be transmitted. This is the address for this to be sent. And we will have to configure the CSN and the CE and the CSN pin of the NRF24 module. And after that, we set the data. Let's remember that the size of the data should not exceed 32 bytes. So which will give us 32 of 8-bit channels. So this should be configured like this structure. You can have the data name, my data. I'm using since it's a drone transmitter, I'm using this 6 byte, which is the throttle, the yaw, the pitch, the roll, and 2 auxiliary data. And I will now initialize my data. And also if our module don't detect any transmitting, we have to reset our data. So this is the reset data method, the function to reset the data. And for the setup part, for the transmitter and the receiver, we will have to include the radio at the beginning, which set up the NRF module, and also to initialize the set auto act to false, and the radio set data rate to RF24 underscore 250 kilobyte per second. And we'll now open the writing pipe to be able to send the data. For this, I'm using this function to control the data to be sent. It will take 5 parameters, which will be the val which will be obtained from the analog pin of the joystick. Remember that the analog pin gives from 0 to 1023 bytes. So the value is between 0 and 123, sorry. So the joystick I'm using is a spring joystick, which always give its initial position to the middle. So we'll have to configure it where is the middle and which part is the upper and which part is the middle one. So the values of these should be measured using the analog read from the transmitter. You'll obtain the minimum value, the middle value, and the upper value of the joystick. Just fill it here. For the total, I'm using the analog read 0. Please remember to measure it, the minimum value, the middle, and the upper value. I have measured mine. I got the 13 my joystick just due to some damage on it. I'm getting 13 at the middle at the minimum value, the 524 and 1015 as the upper value. A perfect one will have 0, with 0 on the minimum, 511 for the middle, and 1024 for the upper. And this one is a Boolean expression which will make it reverse. Like this one will give the 0, 511, and at the upper one it will give the 1023. But if the reverse is true, the bottom of the joystick will be 123, the middle remains 511, and the upper of it will become the 0. So depending on your use of this transmitter, you can set the boolean. And I have this data.aux. I'm using the digital pin, the digital switch to toggle this digital pin to give it either a 1 or a 0. And this using the method to map joystick values. What I'm doing here is to find out if the value is below the middle one. If it is below the middle one, I will set it between 0 and 123. I will map the value to 0 and 128, sorry. And if the value is more than the middle one, I will set it to 128 to 255, which is the PWM signal, and I will turn the reverse. As I've said, if the boolean is true, it will reverse the values. If it's false, it will let the values that. And after doing that, I will do the write the data and the size of the data, which will be this, this one, the light I'm sending. After that, it will send the data. Now let's go through the receiver part. I have included the servo.h library, which because I will be using the servo for this project, and the rest remain the same: the spi.h, the NRF24l01.h, and the RF24.h. And remember, I said that this address should be same for both, for the transmitter and the receiver port also. I will configure my CE and CSN pin as 9 and 10. I will initialize my server and also extract my data, the data that I'm receiving. So for this I have a 7 channel, sorry, don't get this one. So I have 7 channel. I'm sending 7 channel. We can send up to 32 channels, and I will initialize my data and also the function reset data if it does not obtain any value from the transmitter. So I have set up this signal at the beginning to see if my radio module is working, my radio connection are working. I will reset the data at first. I will make the radio begin with the radio that begin function, also the radio that auto act to false, and remember to set the data rate to this one. And I will now open the reading pipe, which will be the which I'm giving a value of 1, and the pipe in which is the address of the transmitter and the receiver. So this is the address of my transmitter and the receiver, which will allow it to communicate. After that, I will initialize the radio that start listening function, which will make the radio mature to start receiving data. And I have initialized the digital in 2, 3, 4, and 5 for my outputs, and also assign a long loss receive time. This is to know if the if we are still receiving data and or not. The radio module will keep a time where it has when it has received the data, so we'll initialize this variable receive time, and we'll also check when the data is receiving. We will give the variable this time when it has received the data. So read will read the data from the transmitter, and after that, on the void loop, we will receive the data. This data, when it will continuously receive the data on the loop, and will add this now variable, which will give the actual real time, so that we can compare it to the last received data and the actual time. Now, if we take the real time and the last time we obtain a data, and if we see that it is greater than 1 second, we can say that we have lost the signal and we will reset the data, because you cannot let the data, if for example, for a uh, motor or the throttle of an plane, we cannot let the data the same. If we stop obtaining data from the transmitter, as our brain will flew out. So we'll reset the data, and we will have this is the digital pin which I'm using to light up and turn off my light, and I'm mapping a variable of the throttle, since our throttle is initially in at the middle, which is which gives a PWM signal of 100 to and 28 to 255. If we don't map this, we connect the PWM signal directly to the throttle. It will turn on the DC motor at the beginning, as it will give a value of 128 at the beginning of when you turn on the receiver, the transmitter. So we'll mark this value between the upper part of the joystick to 0 to 255, so that the middle of the joystick will be 0. We send a 0, and the upper will be a 255 PWM signal. And for the server part, I'm mapping this data to the PWM signal of 0 to 255 to 0 to 180 degrees, which will be used to control the server. After that, I will write these values to the server, the int.val1 to the server, and this was just for testing after a little bit. Yeah. Now now the car for the motor DC motor, I have to check if it is greater than 0. If we don't check this, my joystick will send a negative PWM signal to this motor, which will make it work. So I will check if the value here is greater than 0 for it to work. As if it is not, we set the value of the PWM signal to 0. The 5 is the one in which the DC motor MOSFET gate is connected. After that, I have what this to check if our transmitter is working well. I will now to enable to, if we don't have a cathode ray oscilloscope, to see how the pulse width is modulating, how the pulse width is moving. We can use this serial monitor to watch it. Let's now see this. I open my serial monitor. As you can see, it giving the initial value, the reset data value. This is because my transmitter is not turned on, so I will turn on my transmitter, connecting the wires here, the negative one, and turn on my transmitter. Once turned on, you can see the change in the values. It's giving me the values it is receiving from the transmitter. If I move my throttle, you can see it is changing the values and moving it down, make it 0. The U1 also, you can see it's changing the pitch, the roll, and also the trim. And for the aux1, you can see the digital pin either to 1 or 0. 1, 0 for the aux, 2 or 0. So that's it, my friend. I've gone through this. You will have the code for the transmitter and the receiver in the link below that I'll be leaving. So I hope you guys enjoyed my video, and if you like my videos, please subscribe to my channel and hit the bell icon so that you will be able to get notification for my next videos, and support me through your subscription so that I can make more videos like this, share my knowledge about the Arduino, etc. So goodbye, my friends, see you later.